powering a connected future for people, enterprises, and things everywhere. The connected future is here. It's in upstate New Hampshire, where a freelance writer works online at home, far from the city. It's in Colombia, where a shop owner sells affordable Wi-Fi and internet access to rural villagers. It's in the Southwest U.S., where a fast casual restaurant chain can analyze data to improve the online experience for their customers. It's in a military base in the Middle East, where service members connect with family and friends half a world away. It's in the Congo, where a mobile network operator extends cell service to customers in hard-to-reach places. It's in India, where healthcare providers in towns and villages take online classes taught by experts from major urban clinics. It's in the air, where travelers work or watch the latest movies and news no matter where they are flying. Making these connections is what Hughes is all about. We are industry leaders in both networking technologies and services, innovating constantly to deliver the global solutions that power a connected future for people, enterprises, and things everywhere.
Welcome back to the APSCC 2020 Live Conference Series. And today's webinar is the industry impact of flexible satellites, and it's brought to you by Hughes. Very pleased to have their support for this particular webinar and for the series in general. Joining us today is Graham Shaw, who is our moderator for the discussion this morning from Argosat. He'll be joined by Dave Rabin from Hughes, Didier Lebauche from Thales, and Pierre-Francois Deval from Airbus.
Okay. Well, hello, everyone. Good morning, good afternoon, and good evening, I think, is the right thing to say. We're going to talk today about flexible satellites, which is obviously a hot topic in the industry these days, and in particular how flexible satellites can benefit satellite operators and users, and what the implications of flexible satellites are. So I have a couple of slides before we ask some questions, just to set the stage. The first slide here is just showing really what has happened with high throughput satellites over the last 2 decades. From an economics perspective, as we know, high throughput satellites offer better bandwidth economics. And the first generation of 8 high throughput satellites around 2000s offered throughputs of 10 to 20 to 30 gigabits per second. And when you worked out what they cost and amortized the cost over the lifetime, their Capex per megabit per second per month came out to around $100 per megabit per month, which was significantly cheaper than wide beam satellites, which is one of the reasons why they became attractive. As the technology advanced and the next generation came in around 2010, that amortized cost dropped significantly to somewhere between 10 and 50 megabits, $50 US dollars per megabit per second per month. And where we are today with the current generation of HTS satellites, the very big satellites, which we usually call VHTS, very high throughput satellites, those have Capex per megabit per second per month less than 10, significantly less than 10. And what's happened here really is that we've found ways of forcing more equipment onto the spacecraft. And really the art has been to minimize the marginal cost of addressing each user. Each user on the ground costs a little bit of your resources on the spacecraft, power and bandwidth. And by building bigger and bigger HTS spacecraft, and in particular by having smaller and smaller beams, spot beams, and more of them, we minimize the marginal cost of the user. By having a smaller beam, we let physics do some of the work in providing the gain, thus reducing the satellite power that we need to provide to address that single user. And by having smaller beams, it means we can push more beams into a given coverage area, and that increases the spectrum reuse. Combining those two things together, we end up with a situation where a satellite, an HTS satellite with smaller beams and more of them, can address more people more cheaply, which is why we've moved down this curve, and this curve is on a log-log scale, so it's almost exponential. So that's been the focus of attention for the last 15, 20 years. What we've seen recently, however, is the emergence of flexibility, which pulls the economics off this curve in a beneficial way. And the reason why this is interesting is not every market can support a giant spacecraft. There are some operators who don't have access to giant markets and can't support a big spacecraft. And there are some markets where the coverage dynamics don't suit a VHTS. And so that's one of the reasons why flexible satellites are interesting, not just from a flexibility standpoint, because they break you off this curve a little bit. So let me go to the next slide. So, and we're going to come to our first question in a second now. So as I described, flexible satellites can improve your economics without necessarily having to build a big spacecraft. The most obvious way is that the flexibility allows you to improve the fill factor. You do not typically, if you're operating a fixed beam satellite, have all beams fully utilized. Some beams are utilized and some are empty. With flexibility, you can allocate bandwidth more accurately to the demand, trapping less capacity, which means that you have wasted less capacity on the spacecraft, which means you're using your capital a little bit more efficiently, which obviously has an economic impact. The second area is a little bit more complicated to explain, but I won't go into too much detail. But by having electronically formed beams, you can make them arbitrarily small. Normally with a fixed beam satellite, a traditional satellite, you're limited in the number of beams you can have based on the number of feeds you can accommodate, which means if you have a very big area to cover, your beam size is limited by the maximum number of beams you can accommodate on the spacecraft, and you can't really make a beam much smaller than that, otherwise you would have gaps. But with a flexible satellite, with these flexible payloads, you can create beams arbitrarily small, limited by your antenna size, and just make the beams very tiny, but they would have very small amounts of bandwidth, or you wouldn't illuminate them all at all times. That means that you decoupled the coverage from the beam size, which means that you can create very small beams with very large coverage areas, which gives you a lot more flexibility to manage your capital and make a smaller satellite in terms of power that addresses more people. So it's more capital efficient because it's a smaller satellite, power and hardware to address the same market. Another factor, which is not necessarily flexibility, but is capital related, is a flexible satellite allows you to phase your gateways. You don't need to deploy all your gateways at once. You can deploy one gateway and address the whole market. And as the traffic grows, increase gateway rollout, which simplifies your regulatory environment, simplifies the OPEX and the logistics of starting the business, which is a big impact on the start of the business when you're spending a lot of your money. So these are areas that are benefits of so-called flexible satellites that don't relate to flexibility as people typically think about it. So all of these things ultimately result in an improved cost per usable megabit per second, which can have a massive impact on the business case. So with that in mind, the question asks, do these advantages mean that flexible satellites will displace HTS satellites in general, or these newer VHTS satellites that people are spending money on? And so I want to put this to the panel, and I want to also use this opportunity to have the panel explain a little bit, introduce their platforms, both in VHTS and their flexible satellites, and what their plans are. So I don't know who's first. I guess Dave, do you want to start since you're on my screen first?
Yeah, I'd be happy to start, Graham. From the Hughes perspective, we're obviously not manufacturing satellites. We're a satellite operator, as well as a producer of ground systems, VSAT systems, the Jupiter system. Our next satellite that we're going to launch in 2021 is the Jupiter 3 satellite. It's more than 500 gigabits, so I think it falls into the category of a VHTS system. And of course, we have a ground system that complements that satellite. In the context of the question that you asked, I would just make a couple observations regarding what Hughes has done. With regards to our Jupiter 3 satellite, again, more than 500 gigabits. Actually, flexibility per se was not a requirement for this satellite. We know exactly where we need this capacity. And more important than flexibility is cost per bit and capacity density. Now, all things being equal, meaning if we can get that cost per bit to the right point and we can get the capacity and capacity density, then flexibility, no question, would just be an absolutely fantastic thing. But for us,
and by density, you're referring to the amount of capacity you can place in a small area in the high demand areas.
Exactly. When we look at our service area, there are pockets of places where we have a high number of subscribers, and we want to be able to address that demand effectively. But backing up just a little bit, when we look outside our core market of North America and particularly consumer, flexibility is hugely interesting, particularly when it comes to applications where demand is uncertain or transient. Obviously mobility is just a key factor, or new markets. So that's we no question we see flexible satellites being important. Just in the context of Hughes, I just thought I would share some observations.
But even in the US market, where your primary interest is capacity density, do you not think that the technologies involved in these flexible satellites that would, in theory, allow you to get very, very tiny beams in the coastal regions, very tiny beams, and have much bigger beams elsewhere, or have beams that are not active all the time, wouldn't that also benefit that business by increasing the capacity density?
Well, I think it's a matter of as the technology advances. I think we ordered our Jupiter 3 satellite 2 or 3 years ago, and I think state of the industry didn't allow us to achieve this capacity density that we wanted. Yeah. I'm sure Didier and Pierre-Francois can talk to what's possible now. Maybe the equation would change now.
Yeah, I think that's a good segue. So I guess we'll start with Didier. Didier, if you would, could you maybe describe the work that is going on in your company to develop these flexible satellites, what your platform is, and maybe comment on whether you expect it to take over your sales?
Yes, with great pleasure. I was a bit surprised by this question on whether flexible satellites will replace VHTS satellites, because the generation that we introduced a few years ago were already quite flexible. They were called, in our terminology, VHTS satellites, because they are providing half a gigabit of throughput, the same class as Jupiter. But we have taken the decision to digitize completely the repeater, offering a first level of flexibility, which is complete flexibility in terms of gateway rollout. You can start with one single gateway. You can allocate any piece of bandwidth with a granularity of a few megs per beam as you want. And so you can really adapt to traffic. But it's not a fully flexible satellite, because the antenna configuration that we embark on those large satellites, it's using the SpaceBus Neo platform. And the antenna is an analogic antenna where you have to decide in advance what will be your coverage, where you steer the beams, and where your user density will drive you to have very short and small beams to have the maximum gain, and where you can relax performance of the antenna, having broader beams to cope with a broader area, knowing, as you mentioned very rightly, that you cannot embark an infinite number of beams in your satellite when it's each beam is associated to a given hardware. So this first generation of VHTS satellites were already quite flexible, but you need to know where you want to address the users, and more or less also to have a good idea where it's worth to invest in very narrow beams and where you can address a wider area with wide beams. Then we felt that this type of big birds were very good to drop the cost per megabit and to reach a famous threshold of less than €1 million per gigabit of full investment compared to the data rate you provide. But it was quite intensive in Capex, and some operators could invest in that, but some would consider this investment as a bit too big. So we started to think to a smaller spacecraft, don't targeting half gigabit capacity, more in the range of 100, 200 gigabit per second. And the evolution of technology enabled us to change the antenna, to move from analog antenna to digital antenna with a digital beamforming. So it's a full active solution. And in this case, you can not only allocate more bandwidth to some beams, but move the beams, change the shape of the coverage, even change the type of service you offer, because you can transform in Ku band a DTH spacecraft into a HTS spacecraft. So it's much more flexible. But we don't believe that they will replace completely the VHTS, because if you know perfectly where your market is, if you are in America or if you are in China, the border of America will not change tomorrow. So you know where the user density is, and you could really optimize a VHTS spacecraft, and you would reach an economical point that will be, we believe, as good as what you can get with a smaller spacecraft. So I think the two will coexist for quite a long time.
Okay. Pierre-Francois, do you want to follow up also about Airbus? Pierre-Francois?
Sorry, I was muted, sorry. Yeah, so I'll follow on Didier's and Dave's remarks. Obviously, as a manufacturer, we have, I would say, a similar position to what Didier was explaining, is that the fact that we see both coexisting in terms of satellites to be manufactured. We do have currently, well, we do flexible satellite. If I go back 20 years ago, albeit in a lower MSS band, but that was for the same reason at the time, that in order to cope with the kind of traffic that they had to accommodate, the flexibility and the digital beamforming was already required. Obviously, the technology at the time was not allowing it to offer it for the HTS or VHTS throughput, but clearly there are different level of flexibility, as Didier pointed out, and we have to, in our portfolio, from the Eurostar Neo and Eurostar family, which is our best seller in terms of big geo satellites, we offer flexibility into that satellite, but not to the level of full active antenna in Ku or K. And we've introduced now a bit more than a year ago and sold already 4 of them, the OneSat series, which is a fully flexible Ku or Ka satellites, active antenna, full processing, and in receive and transmit. And clearly those satellites are answering, I would say, a different type of market. As pointed out by Didier, the Capex is actually, and the Capex allowance that our customers can offer, allow, is key in choosing one solution or the other. We actually even see a potential virtuous circle, which is when you don't know the market, you test it with a OneSat. You have the flexibility to adapt to the exact type of service you want to implement. When the business really develops and you see that there is the capacity required for a larger satellite, that you can gain again on the economics by moving your flexible satellite to another location and introducing a more what some people call brute force, which is when you know exactly what sort of service you want to offer and what type of coverage, then you can do it in an even more efficient way. And also pointed out by some of our customers, or actually by the market demand right now, we see also customers facing uncertainty in their current revenues. DTH is the perfect example, where most of our operators and customers are saying, I have a strong revenue in DTH, possibly declining. How do I go from one to the other? And again, the full flexible satellite is the right solution to answer to that. So it's really a question of Capex allowance, I would say, versus market certainty. And then the last point that flexibility enable, I would say, and I think we'll touch on also later on that, is the ability to standardize the satellites and have generic satellites which could answer many needs, and then you go into a different economics of producing the satellites.
Exactly, and I think you raised a very interesting point there, which we didn't touch on, which is the fact that a flexible satellite, it can be an HTS satellite for data, and it can be a DTH satellite for broadcast, or it can be both, and it can change its character over time, which gives a nice transition plan for some operators that are moving from being a linear TV broadcast supplier to a non-linear TV type overlay supplier to Netflix and Amazon, and to data and internet. So it gives them a gradual transition plan, as opposed to a discrete Capex event where you're gonna abandon one business plan and go after another. Okay, that was very insightful, and I think this was a really good question. So I have a follow-up questions, or several questions here, which is, how will people, there's several questions here, but how will people actually use these flexible satellites? And this, I was talking with Dave offline, and there's some question here about, do you anticipate that operators will make changes to their spacecraft slowly as their business plan evolves, which is, I think, what most people assumed at the beginning of these flexible satellites, or at least that was the value proposition initially. Or will we start seeing the evolution where the flexibility is applied on shorter and shorter timescales, so that we can be truly dynamic on a daily basis, or even an hourly basis, or even within a TCP frame, to track customer demand or change the type of services? Is that feasible? Is that something that could happen? And so that's my first question for the panel, and I guess I'll reverse the order. I'll go straight back to you, Pierre-Francois, on this, and then we'll cycle through.
Okay, so yeah, very good point. And actually, from what we have seen in the last couple of years with our customers and the various operators, the span of dynamicity, I would say, is quite large. Ultimately, effectively, there is the goal to go down to a TCP frame or IP router. I would say this is already coming in some constellations work, for instance. But clearly, that's I would say a major system that needs to be deployed, and the complexity of the ground system that you have to do for that, the regenerative processing on board, is stepping up, I would say, the cost of flexibility that you want to implement. What we see in a more conventional, which is I would say change of configuration from a few times in the lifetime of the satellites down to the hour or the minute, is something which is much more common. We do see customer that at the start will want to be just able to change, for instance, from DTH to HTS when the need comes, but not very rapidly. Then they will have, I would say, all the customers that want to have the ability to adapt to the seasonal or diurnal variation of the traffic. And all of that comes to the point where when you are faster and faster to adapt to these changes, I would say you avoid the oversizing of your system, because you can really allocate always the capacity of your satellite to the exact needs, not having to sum, I would say, the worst case peaks of the various hours of the day or whatever, if you have to change only a couple of times a week or a day. So clearly the need is there all from the whole scale. Our satellites are designed so that they can do it several times a second. So you can change configuration basically in a very dynamic way. As I said, not necessarily to the packet level, because then it goes to another layer, which is the regenerative processing and the adaptability to the various area interface, which could evolve. But clearly, changing configuration from seconds to hours, days, there is the whole scope. Then the question mark is how much you want to invest in your ground system, because that's the next step, which is how complex do I make my ground system to actually interact with my satellite. As a satellite manufacturer, we do offer this possibility, because we recognize that there is no point having a flexible payload on board if you don't give the I would say the operating system or the software to drive it from the ground, including in completely combined with your SRM. But then the SRM is another topic, because operators and customers have various position on what they want from satellite manufacturers.
Yeah, I think maybe that's a good question to ask Didier. I mean, in order to, as you described, to get the maximum benefit of the flexibility, you have to be able to allocate the resources in the network, the bandwidth resources and the beams, and allocate them to the various users and user terminals. And that the timescales over which you're doing that depend on your planning horizon and other things. It's very complicated. So it's not something that the operators are ready to do at the moment on their own. So I guess, Didier, do you have opinions on how that might be done, and who would provide that software?
It's a very, very good question, because when you offer such a flexibility to customers, this flexibility is huge and needs to be managed, and in a way that the operators on the ground will take maximum benefit of that and not be very worried by this huge amount of flexibility. So it's part of the development of our flexible satellite to develop the tools on the ground that will support these operations. We cannot conceive to give just a satellite and operators being unable to exploit this huge flexibility. But it's right that the dynamicity of this flexibility is very important. If you just want to reconfigure the spacecraft once a month because the traffic is slowly changing, it's not the same tool if you want to manage as traffic grows and on a daily or even more quickly basis. And so as part of our solution, we have an internal tool. We are open also to collaborate with people that would develop this kind of tools for operators that would like to have their own mastered software in order to be compatible with any type of provider.
And is this something that can be purchased and plugged into people's operation systems reasonably generically, or is this something that has to be customized for every operator depending on how they're structured?
I don't really believe that it could be completely off-the-shelf plug-in solution, because it's intimately related to the payload and to the way it works and to the way to program both the antenna and the processor. So I believe that the manufacturers have absolutely something to bring to that.
Well, actually, my question was more: is it something that you could create a product that you could sell with the satellite to anyone, or do you have to work very closely with every operator and create a different tool for each operator?
I think it's both. We need building blocks and bricks that are linked to your spacecraft design and to the dynamicities that you offer. And this is under development. It's really part of the space segment development. We need to develop that. And it's not a brand new product. It's an evolution of our DAMA type of software that we have sold since many, many years with our more conventional spacecraft. But here you have so much flexibility to propose that you have additional levels, additional things to tune on the spacecraft that you can play with. And so this is managed by the tools. But we are also possibly customizing this tool to specific needs, because when you start to do that, you enter in the field of managed services that our dear customers want to offer. And this is very close to their business model. And so they want to take part of that. So
yeah, so you get some overlapping of roles and responsibilities. You're moving a little bit down the value chain. They're moving also down and up the value chain. There's a lot more overlap. I can see how that confuses things. I also think that it's something that the operators need to budget in their capital planning, that they're not just buying a satellite and a ground system and a dynamic satellite simulator. They now got to budget, I think, to in time and in Capex to implement these systems.
Yeah. It's not free, but it's not the size of Capex of a satellite.
Okay. And a question for Dave. Dave, how does Hughes today manage its its capacity? I know that, I mean, you do have some flexibility on your spaceway spacecraft. The rest of them they have some flexibility. Do you make changes reasonably frequently, or is it quite static?
Well, you mentioned Spaceway. That's an interesting use case, because that satellite's extremely flexible. But of course, that was the Spaceway 3 was launched, I think, in 2006 or something like that. Extremely flexible, but limited capacity. But of course, as I mentioned before, our market focus changed, where, again, capacity density and cost per bit was more important, and we knew exactly where we needed the capacity. But today, we are adopting our Jupiter ground system to support flexibility. In the near term, the use case that we're accommodating is for mobility, particularly aero mobility, where the time scale for reconfiguration is more on the order of an hour. And so, when it comes to the ground system, the challenge there is, distributing the new frequency plan in a timely fashion, of course, synchronizing it with the satellite, and then the tuning and acquisition times for the carriers. I don't think we're yet at the point where we could do it minute by minute or second by second, but certainly we're planning to support hour by hour flexibility changes, and I'm sure the technology will improve.
And you mentioned aero. I think there are aero is an interesting market, as you, I'm sure, are aware. There are waves of flight routes that typically, a wave takes off from the US and goes over to Europe, and another wave later comes over from Europe back to the US. And in Asia, it's the same way. You've got waves going from Asia to US or from Asia to Australia, and they happen at specific times. And I guess with the correct kind of flexibility in the system, satellite, but also the ground system and the resource management, you can allocate bandwidth and beams to follow these waves. In the limit, I suppose you could have a beam for a satellite for a given aircraft. Every aircraft would get its own beam that would follow, and extending that a little bit slower, a bit easier. But also in the cruise market, is very seasonal, right? So you have certain areas that are popular at certain times of the year and others at other times of the year. So I think that's an area where these, if done correctly, this combination of an intelligent SRM with the flexibility offered could greatly improve the utilization of the satellite.
Yeah, that's exactly our view, particularly in the near term. Those two use cases that you just cited, that's precisely our view.
Right. Hopefully we'll see a return to cruise after this COVID and return to aero also. Okay, so my next question we won't really spend a lot of time on, but in the limit, if you keep on reducing these timescales, eventually you get to beam hopping, right? Which is where it is very similar to beam forming, where you're electronically forming beams, but instead of having fractional bandwidth in each beam, the idea here is that every beam has approximately the same bandwidth, but you dwell in a location only for a fraction of a second, and you hop the beam around to follow the demand. And you might have, any instantaneous time, you might have tens or 100 instantaneous illuminated beams, but every few milliseconds they move and hop around. It turns out when you do the math, there is no flexibility advantage to having beam hopping versus having beam forming. They have the same degrees of freedom, so you can create any arbitrary distribution of bandwidth within your granularity. I think the only real difference when you do the math, I believe, is that because beam hopping concepts, not all the beams are illuminated at once in time, they are generally further apart. Co-frequency co-beams are generally further apart, and hence have slightly better interference performance, so their C over I performance is a little bit better, which can mean that you are not C over I limited for certain markets, so you're more power limited on a link basis, which in some cases can mean a higher spectral efficiency, but not always, because sometimes you're not limited by C over I anyway. I know that this is the topic of research in many companies, and I know that certainly in the LEO systems are the big LEO constellations like Starlink and Telesat LEO are doing beam hopping, and I believe it's this topic of research at the GEO also, and we see it in some business cases, but it does come with some complications, right? Particularly in terms of what it means for the ground equipment, the ground terminals, and the gateways, which need to be all synchronized. So my question is, first of all, I guess the question for the two manufacturers on the panel, and we'll ask both, is are you currently working on a next generation of platforms that support beam hopping? And if you are, I guess why? And I'm not saying you shouldn't. I'm just saying, what are the reasons why you think that's worthwhile doing, and what are the challenges involved in that, in operating that system? And a follow-up question, which I'll direct to Dave later, which is about if we end up having beam hopping as an interesting or as a valuable business proposition, does it mean that every network's going to be running on its own set of proprietary user terminals and hubs, or can we have any standardization to support manufacturing economies of scale? So I guess I'll start this time with Didier. I think that's right. Yeah, Didier's first to go this time.
So first, I agree with your statement that if you do the math, you have the first level impression that beam hopping or beam forming in a digital world will provide more or less the same performance if you just look at the satellite level. But if you include a ground perspective and take into account the full system, we have seen some customers asking us to embark beam hopping capability in our next generation processors, the one that we developed for the Space Inspire. So at the first glance, we were a bit wondering why, and then we understood that it's linked to the legacy ground modems. Some modems are not capable of generating multiple carriers, and so addressing many spots at the same time with the same piece of hardware. And so if you want to minimize the hardware on the ground, you could find an interest in having a modem transmitting one big carrier and distributing this carrier over across many beams using the beam hopping.
On the gateway side. On the gateway side.
On the gateway to the user, yes, on the gateway side. And then, of course, the user terminal needs to be capable of receiving on and off signals and not do the synchronization when the signal is not anymore eliminating the beams in which they are sitting. So there is a challenge associated to that. First, technological challenge, because your processors need to be quick enough, fast enough to generate this beam hopping at the right pace. And there is a system level challenge, because as you mentioned, there is a need for synchronization, from end-to-end synchronization between the gateway, the satellite, and the users. And so the first challenge is a go, no-go decision. Either you decide to go there or you just skip this functionality, and it's difficult to go back unless you develop a new solution. So we have decided to implement that in our next generation processor, even if few customers are requesting for that, but it's such an investment that it's worth to do it right at the first time. And then for the end-to-end system synchronization, it really depends on the system you want to operate, because some users will stay with DVB type of solution that will not mandate that could be implemented in the new DVB S2X standard because it incorporates beam hopping, so it's a possibility. Some users could decide to use proprietary systems, and then the synchronization of those will depend on what they want to do. And then we believe that over the next 5 years, 5G will start, the new standard coming from terrestrial networks will start to pop up in the satellite world. And 5G sometimes is using TDD, which is a time multiplexing of transmit and receive over the same channel. So in the field of satellites, we usually have different bandwidths for receive and transmit, but nevertheless, we can use the TDD also in satellites and even in GEO. So for instance, on Iridium, we have based or developed the full solution with the TDD approach in L-band. And we believe that this could also happen even in HTS and VHTS for the future. So this will be a bit system specific, depending on what the users want to do on the ground. But in terms of spacecraft, we are ready to implement these functions as soon as 2023.
2023. And I think you mentioned that the satellite payload itself, once, if I'm an operator and I buy one of these satellite, one of these smart, these flexible, capable spacecraft, I can choose to operate it in either beam hopping mode or in static mode, right? It's not one or the other in terms of the operation.
Yes, you can choose. It could be a bit complicated if you want to operate both simultaneously, because maybe you will have to segregate this coverage to avoid the beam hopping to jam the guys that are not hopping. So you cannot do crazy things, but the capacity is given. Okay,
that's very good. So Pierre-Francois, I believe Airbus is also embarking on something similar. Do you want to comment on that?
Yes, yes, we have a similar, I would say, approach to what Didier had described. We see beam hopping as a need which is expressed by some customers, not all of them, but definitely when you are considering the investment in the new generation of processor, it is worth effectively embedding the beam hopping capability from the start. What we clearly see is that it's easier, or the customers that are actually looking directly for beam hopping are the ones which are basically starting from scratch. It's much easier when you do a complete system. You can design it from end to end, beam hopped with you don't have the rollout of new user terminal to do, because you have to change them from non-beam hop to beam hopped. So it's obviously easier, and that's something which we clearly see. That's why the constellations are done that way. It's also the fact that when you have started to do you are going the route of channelizer and beam forming, the advantage of beam hopping is reduced somehow. There are some advantages. There are some application as mentioned by Didier, but if you look at it, the complexity that you have to add needs to be traded with the actual benefits you get. But we have this demand, and we have the capability of offering beam hopping on top of beam forming, or one or the other. It's really something where we are flexible to the customer needs.
I think something you said there really struck me, and it's something that I think operators, maybe if anyone's listening to this or watching this, in terms of transitioning from an existing business, it is non-trivial to move to a beam hopping solution, because you have to do truck rolls of all the user terminals in the network and implement a completely new system. And it's not something that's easily done. As Didier said, it's not something you can transition to, because it's difficult to do dual illumination. So you would almost have a day where you'd have to run all the trucks out in a given region, and then turn off the static beam and turn on the beam hopping solution. And it would be, I can imagine it being an absolute nightmare for legacy players. I don't know exactly how to do it.
It's probably something more than some operators rightly consider as for some specific services, and possibly by segregating either by coverage or by part of the spectrum, which will be beam hopped and not the rest of it, so that they basically segregate the kind of services they offer, and some of it will be beam hopped, but not the rest, so that they can introduce that as a new service.
Right. And with that in mind, here's a question for Dave now. So given the difficulty of standard, well, if for legacy players who already have a lot of customers out there, and by definition, the legacy players are the ones with the most customers, and hence the biggest purchasers are the people who are responsible for the most sales in user terminals. Does this mean that, do you think, that it will be difficult to get traction for these beam hopping type user terminals, because the only users of them will be startup operators or startup systems?
Yeah, I think that it certainly makes it, the logistics makes it much more complicated. You know, I would observe that I recall, I don't know, 3 or 4 years ago, quite a few of the operators were asking us about beam hopping functionality. But that most of those operators, bar a few, seem to have moved towards the beam forming approach. So I would just make note of that. Having said that, our next generation ground system, our next system on a chip, which is embedded in all of our remote terminals, as we start shipping out those next generation remote terminals, they support the capability for beam hopping. They support the DVB S2X Annex E, you know, which enables you know, super frame synchronization.
Exactly.
Now that doesn't constitute in and of itself a beam hopping capability, but it's certainly an important element in being able to support it. So I certainly think that over time, remote terminals will be populated in the field with the capability to support that, but at a system level, there's just a tremendous amount of work that needs to be done in order to support beam hopping. You know, we're very confident we know how to do the synchronization of the gateway, the user terminals, and the satellite, but still, it's quite a, you know, it's quite a complex thing to do beam hopping, and it's not clear to us that the benefits have been fully explored.
Yep, I would tend to agree with that. Okay, so I'm changing topic a little bit. Oh,
yeah, if I may add one point. We were just discussing the GEO landscape, and I think we all agree that in the GEO you can work with one or both of the technology. But if you look at lower orbits, like smaller satellites, LEO type of constellations, then the trade-off could be slightly different, because when you implement beam hopping, you can avoid to have digital beam forming, and potentially you can have processors or dimensioning of the payload that is a bit less consuming, a bit lighter than if you
need less beams, essentially less channels on the network, less channels on the processor.
Yes, and you can accommodate many beams in an analog way that will not use a lot of power, and distribute the capacity between them. And so, for depending on the size you are targeting in LEO, the beam hopping could be, in certain cases, a very efficient solution to reduce the consumption of the payload.
Yeah, I think that is why we have seen it as the default case in the announced, you know, the big announced constellations. But it's very good point.
It goes also, if I may, with the fact to go to regenerative and onboard routing at IP level, because when you are doing that, you are leaving, I would say, the world of channelization and routing at channel level, because you do it at packet level. And when you do that, then you have effectively a sweet spot of using beam hopping and regenerative compared to digital beam forming and channelization on frequency.
Oh, that's interesting. So once if you make a decision to go regenerative with a you know, mod on the spacecraft, then some of the simplifications that come from having a transparent processor and channelizer go away anyway, and then you can do the beam hopping at the packet level, or at least at the as you assemble the frames. That makes sense. Yeah, I'd not thought about that before, but that's correct, I suppose, is that the calculus about what makes sense changes once you start moving the technology toward the packet level.
But if we start going towards regenerative satellites, then don't we start moving away from some of the benefits of flexible satellites? Insofar as my understanding is that with flexible satellites, you have a standard payload, and Because it's standard, it's not unique for each customer, it's quicker to market, and as well lower cost because you're not spending the R&D or NRE dollars for every customer. So it seems to me we would start losing some of that benefit.
Well, you know, that's a really great segue into my next section. Thank you, Dave. That was almost like you had a preview, but it's a good point, which is, can you truly make a universal or a standardized regenerative payload that can survive for 15 years in GEO without requiring significant technology refresh? Because one of the things in LEO is that you have a more frequent technology refresh, which, you know, allows you to be more confident that your modems on the spacecraft are going to be able to accommodate the changes in the formatting over their lifetime, rather than in GEO trying to build an ASIC today for the mod demod on the spacecraft, anticipating where the most likely modulator formats or standards are going to be. It's much more difficult, I think, and so that's a good point. So that brings up my next topic, and really kind of the last topic we're going to have time for, which is, we've talked about flexibility in terms of the operations side of it and the functionality it offers and how it changes for the operator. And now what I want to talk about is how you build the spacecraft that's going to provide that flexibility, because that also has huge impacts on the industry and on the types of customers. So the end game here, I call it on this side solid state satellites, but I think we could also say software defined spacecraft, which is, instead of custom building a spacecraft that is bespoke and unique to every operator and every orbital slot, the goal is to create a reasonably standard spacecraft that has the same components for every customer. It's essentially the same spacecraft for every customer, and the customer configures it on orbit to meet its needs. You can achieve this through the use of, you know, software-defined radios and digital processors and phased array antennas or electronically formed antennas, electronically formed beams, such that all the spacecraft have and a processor. All of spacecraft have the same components. What that means for the manufacturers is that they're building the same spacecraft every time, which means that they can change the way in which they are planning their production. Instead of requiring a significant design phase for every customer, it's more of a manufacturing exercise once the design is done, which reduces the build time because you eliminate the front end design period, means that you're amortizing your non-recurring engineering over all your customers for that whole generation, as opposed to doing a lot of non-recurring. In theory, you're buying a lot of solid state devices and they're all the same, so you can get mass manufacturing economics on the components. In terms of the way you finance the satellite, if you're an operator, can change because the satellite is totally fungible. I can resell it to anyone, and I can use it across all my slots and across all my regions. So it has enormous fungibility, which changes the way that you create your financing package, and can change the way in which you buy the spacecraft and plan to use it. As we talked about earlier, it has the same benefits as other flexible satellites in that it's adaptable to all missions. And so I can buy it thinking I'm going to use it for broadcast and later use it for data, or vice versa. If everything is the same, then the satellite manufacturers can actually build inventory. They don't have to build on order. They could actually build according to the most efficient manufacturing plan and sell them as they, as orders come in, as opposed to building them as orders come in. And so that separates sales from manufacturing and allows the manufacturers to run more of a factory, just the same way that they're doing with the LEO satellites. When you add all this up, the thought is that the spacecraft will be significantly cheaper, less capex, less risky because I have less market risk and less technical risk. I've got manufacturing type risks as opposed to design risks, and I get more utility. And so the postulation is, if we achieve all this, and I think we're close to realizing it with the products, the Inspire product and the OneSat product, and I know the Boeing has one also. Do we see this being completely replacing bespoke satellites, or at least significantly replacing bespoke satellites? Are the economics so strong that we will see operators make that call that it may not be perfect for my needs, but it's good enough? And I'll tell you, I have some history in this. I tried to get this going 15 years ago when I was working at a manufacturer, but we just didn't have the technology. And I couldn't persuade Intelsat or SES to do anything that we just didn't have. We weren't there yet, but I'm excited that I think we are close to there now, and that we don't need bespoke RFPs. We don't need bespoke specifications. So, and I'll come back and do the last question later. So I guess I'll put this one to Pierre first, Pierre-François.
So yes, I think you're perfectly right. As we discussed earlier, the advantage of flexible and software-defined satellites is not only in the flexibility, but actually, and probably even more, in the genericity and the standardization. It's changing the complete paradigm of manufacturing satellites. And we do see that, yes, we are at the moment where we can I would say, get the benefits and the promised results of that. We've been, in the last 18 months, 40% of our satellites we've sold are fully flexible generic. So it's a significant and successful introduction of OneSat. However, while it will take its place on the market and clearly develop, we still see that there will be also I would say, a need in the market for more bespoke satellites. There is the case of multi-band satellites. Some operators do need to have C, KU, or some other bands which are there, even sometimes the mix of KU, KA, and obviously you can consider to have two OneSats, but then it's not necessarily the best approach for some customers. So we do believe that both will coexist. What we do as well is that we can make the Eurostar family, I would say, satellites benefit or leverage the mass production approach that we are taking on OneSat, which itself comes from OneWeb and what we've done for the LEO. And really, there are building blocks at processor level, at antenna level, that we can and we are implementing on our Eurostar. And the fact that, as I said, 40% were standard generic satellites in our last 18 months, but 80% were processed and flexible. So it's, I would say, basically conventional satellites, I would say, as they will be in the near future, will just be processed and flexible in one way or the other.
I see. So extending on that for Didier, I want to ask a theoretical, if, as we wind the clock forward, if that number, 40% of the generic satellites, if that became something like 80%, so this is really a question for Didier, if 80% of the satellites sold were generic satellites, do you think that it makes sense to maintain the infrastructure and the capital needed at your factory to be able to offer bespoke satellites at a customer?
I think this 80% is already the situation between a digital spacecraft and non-digital spacecraft. If we look backwards, since a few years, we have sold 80% of satellite with a lot of flexibility thanks to digitization. They are not all standard because most of them still have a bespoke antenna configuration to really fit the market. So what we foresee is in line with what Airbus was mentioning, which is a significant introduction of fully standard flexible satellites, maybe 40%, maybe 50% of the market. But we still believe that there will be room for bespoke satellites. If you take many operators that have spectrum in many bands that want to accommodate a limited hosted payload for the military or these kind of things, There is a certain degree of customization we can accommodate on our Space Inspire. We have dedicated one place for a dedicated antenna that can be in another frequency band, and something like 10 to 15 transponders. So this is compatible with a standard spacecraft. But if you if you want to have a 50-50% power allocation between one frequency band and the other frequency band, then you need two Space Inspire, or you need to build a SpaceBus Neo with the two payloads on board.
I see. So it's a way of offering the customers who have legacy needs a means of cost effectively addressing those needs, taking advantage of some of the cost advantages that you offer with the Inspire generic payload. Because my fear was, quite frankly, that we could find ourselves in a situation where it's so expensive for Thales or for Airbus or for SSL or Boeing or any of them to build a bespoke satellite, because your manufacturing energy is focused on building the generic spacecraft, that no one could afford to build a business case around a bespoke satellite because it would be too expensive to do so anyway. But it's interesting that what you suggested is that we can kind of bolt on the legacy payloads that we need onto the generic spacecraft. It's almost like having little customizations on a car, right?
Yes, that's exactly that, because this concept of a standard satellite is a dream since many, many years. And many years ago, we wanted to market a standard Ku-band satellites to several countries. And each time we were close to conclude with one country, we discovered that some countries want a little EGNOS type of payload, S-bas payload on board it. Another one wants 10 military transponders. Another one will love the project with just a legacy 10 channels in C-band. And this is why we have built that inside our Space Inspire platform to accommodate a certain degree of customization. But it cannot be as important as if you have a full bespoke satellite with 20 kilowatts of payload that you can really do whatever you want.
Right. So,
and one thing, sorry, maybe if I can add, one thing we didn't mention, we touched on at the start, which is in some cases where you want to achieve very high density of throughput in very dense urban areas, the standard satellites will have some limitation, not due to the technology that we are implementing, but somehow when you decide to do a standard generic satellite, you cannot design it for the maximum size you want to achieve, because then you will sell less of it because it will be too big. And if you do it a bit too small, it won't. So it's kind of the 150 gigabits spot that Didier was mentioning. We also have a similar sweet spot for our OneSat. And once you do that, if you want to achieve very high throughput and very high dense traffic area, then you need larger antenna, and then bespoke satellites may be the right approach. So clearly the two will coexist, and we have to be responsive to both. Okay,
well, that's a great answer. So my last question or my last comment, and I'll discuss this with Dave. If the economics of these generic flexible satellites if it's cost effective to buy them for a variety of missions, and they're all reasonably generic and standardized, the question I have is, why should a satellite operator own them? In fact, if they're all basically the same, I could imagine it's more cost effective and better from an overall industry perspective for them to be owned by asset management companies like aircraft are for the airlines, where in many cases, not in every case, but in many cases, the airlines don't own their own aircraft. They're operators of the aircraft. And the ownership economics falls to a different entity that has different tax treatments and different cost structures. And so then you start looking at the value network and say, well, a satellite operator, its value proposition is based on its customers and its orbital slots, and they're going to take satellite resources from a separate entity that will own it. And you could argue about who that should be, whether that should be the manufacturer like Airbus or Thales, and you own your own satellites, or whether it should be a third party financial entity. Is this something, do you think, Dave, that that you could ever imagine Hughes going toward? Can you imagine not owning your satellites?
I think that's a little far afield. I would observe that actually owning, there's such a thing as owner economics, as you
right.
point out. And if you have a third party owning the asset, you're not going to achieve as good an owner economics. And that's pretty important for us in getting the lowest possible cost per bit. So I'm not sure I see that in the future for Hughes. But I think what's interesting is where you're going with this is, some of the benefits of these. We've been talking about flexible satellites. To me, some of the benefits aren't so much in the flexibility; it's in the cost per bit, because you don't have to spend that R&D that's unique to each satellite, as well as the time to launch the satellite. That's another advantage, and time to market is also money.
Well, it's money and interest, right? And
yeah.
and that comes back to, I know you don't think it turns out when you do the math, the owner economics, the benefits of owner economics depress enormously when you start shrinking that. If you could make a phone call tomorrow and say, I would like a satellite over this location, and someone has a satellite or has beams over that location, within a month or 2 months or something, then things can change in terms of the economics there as well. So I think I agree with you, and that was I'm glad you brought that up, because I think my objective with this session was to try to broaden people's view of what it means to have a flexible satellite. The benefit is not flexibility. I wish we hadn't really gotten into this nomenclature of flexible satellites. It's really an improved satellite that can offer flexibility and improved economics and improved manufacturing economics or manufacturing industry support. The whole industry can actually benefit from these new kind of satellites, I believe.
So I would just finish up with, I think that there's also a potential for, it lowers the barrier for a new operator to get into the market, in my view. So, who knows? Maybe it changed the market dynamics in terms of the operators in a significant way.
Yeah, I definitely agree. Well, I think that was all. I think we're basically out of time anyway. I think we might have run just a little bit long. But I'd like to thank everyone, thank the panel. At least I learned some interesting things. I think it was very useful for me, and I hope it was useful for the audience.
Thank you.
I don't know if anyone has any questions.
Have a good day.
Thank you.
Thank you very much for that, Graham. And thank you, Dave. Thank you, Didier. And thank you very much, Pierre-Francois, for your insights into the effect that flexible satellites are having on the industry. Also, thank you very much to Hughes for your sponsorship for this event and for your sponsorship and support for APSCC in general. We do appreciate that. We'll be taking a break from this series for the next week and shifting our focus to Connect Tech Asia. It will be a virtual event. APSCC will have a booth as part of the Connect Tech Asia event. We'll be running a series of webinars during the course of that event. So if you haven't registered, please do register now. We'll be joining you back here for the first week of October for the next in our series on India's DTH market. Please join us then. And in the meantime, stay well.